Let's move on to the Arduino Nano part. Since the pins will be parallel to each other, I copy RX0 from here. I rotate it with R and place it on the second pin. We are copying TX1. I rotate it with R and place it. Let's take our D2 pin. You can write the program you use in the comments section. You can express your opinions about KiCad. Yes, we continue our circuit. Let's come to the D4 pin. I copied it. I rotate with R. We came to the D6 pin. We place pins D7, D8, D9. Since I am used to this program, some programs are cumbersome for me. I think it's slow. I am not naming those programs because everyone thinks that the program they are used to is better. However, if you are working maker-based, I think you will like the KiCad program. We finish this part by taking the D13 pin. Yes, let's connect the GND part. I am copying GND from here. I placed it here. Let's move to the front part of our circuit. First of all, we take VIN from here. Let's place the plus 3V3. We also take our 5 volts. I come over and copy it. If you want, you can leave it here and do it in a connection like this. It's up to your choice. Let's take the resets. We are taking our AREF pin. Yes, friends, if you are tired of buying one by one, I select them with the left mouse button. I right-click and select Duplicate Block. This way, we copy them. Then, I rotate this block part with R. As you can see, you can use them like this instead of doing them one by one. Yes, friends, it looks like our circuit is finished. Let's see if there is a mistake. That's why we use the ERC command here. Here, it shows us logical errors or disconnected pins. I do not care much about logical errors because our circuit is correct. However, rules have been set for this entrance, such as this cannot happen. It gives errors like that. I liken it to this. I am doing augmented reality applications in Unity. I do not care much about yellow warnings, but red errors are important to me. There are already errors like the program is not working. If there is a yellow warning, it does not matter much to me. I liken this to it. Before using the ERC command, we need to do it for annotation. It will probably give us his warning. When we say run, it gives this warning. I am closing here. We can call this warning a naming warning. There are question marks here. We need to fix these. We use this command to fix this. I call it annotate. So it named the pins for us. I am closing here. Let's call it ERC again. When we say run, as you can see on the screen, it shows a total of 2 warnings. We were paying attention when it gave an error. If we are sure of the design in warnings, we can continue our process. When we click on the warnings, it shows where there is an error. How can we fix it? We have a command called power flag. I fix it with this command. You can clear such warnings in KiCad with this command. I am connecting this and copying this. Let's connect GND. Yes, let's call it a run again. As you can see, our warnings are gone. If you say you are too obsessive, you can eliminate these warnings this way. As I said, we could continue our circuit with these 2 warnings. Yes, friends, let's center our circuit here. Our circuit is finished. We need to assign a footprint on them, so we need to make PCB equivalents. It does not matter what the schematic shape we draw here is. Make it a triangle if you want. It does not matter. What matters is the footprint response. So we can call it a package equivalent. Do not worry. If there are comments like, the image here does not look like Nano, this is the schematic part of the circuit. The important thing here is the pin assignments. Yes, first, let's save our circuit. We click on the icon that looks like an op-amp or integrated. I call it Assign PCB. Yes, friends, the footprint assign screen has arrived. When determining footprints, I also look at their 3-dimensional version. In this way, I minimize the chance of making mistakes. You can view from this section. This is how I positioned my screen. You can also view the 3D image from here. Yes, friends, as you can see, the PCB equivalent of Arduino Nano came directly. We need to identify the connectors. That's why you come to connector pin, header 2.54. As you can see, it showed the connectors for us here. We need to take 0,1 multiply 15 from here. Yes, friends, you can take it this way if you want. But I won't use this. If you want, you can also choose from the pin socket. There is no difference between the two, because they are both the same size. But we need to use it in terms of visuality. When we double-click on it, it performs the assignment. I come back and check. As you can see, it assigned our pins. Then we save from the File section. We are getting out of here with the OK. Yes, there is one last action left. From here, we come to the Generate Netlist section. At PCB New, we call it Generate Netlist. We save the resulting window as it is. Yes, friends, our schematic part is finished. Our next video will be the PCB part.